Hello, dear viewers. I am Dr. Neil Singh. I'm associated with ABES Engineering College, Ghaziabad, and the topic we are going to discuss today is green chemistry. The contents of the lecture will be 12 principles of green chemistry, conventional and green synthesis of adipic acid and paracetamol, and the impact of green chemistry on environment. Let us start with the topic. So, before we start discussing the principles, we should know what green chemistry is. So let's see what the definition is saying. Green chemistry involves the intentional design of chemical products and processes to minimize or eliminate the utilization or creation of substances harmful to human health and the environment. As you people all know, that after the World War One, Industrial Revolution started, which made us self-sufficient in all the resources required for the upliftment and elevated lifestyle of the human beings. And we have escalated on a good standard of life after that because a large number of industries have been established and we are upgrading as a human on economical platform also. But in the backdrop, more the number of industries are being formed, more waste product is generating, which is getting added to the environment and causing pollution. We know the first concern of global warming and everything around us is environmental pollution. So, in order to balance that, the production and balance the pollution also, green chemistry steps in where it designs the processes in such a way that the process which has been formed to design a substance should be releasing low waste or least waste, or maybe no waste at all. So, green chemistry aims to protect the environment not by cleaning up but by intervening in new chemical processes that do not pollute. So, properly, they are replacing all the existing mechanisms, processes which are adding pollution, adding to the pollution. Green chemistry is changing the methods and reducing the pollution and pollutants. So, while applying green chemistry, while designing a process through green chemistry, we should keep three things in mind. First, that our process should be environmentally unique from the alternative practices. So, whatever the process which was being taken care of or used in the previous and conventional way, our new method should be environmentally friendly and as compared to the existing practices. Second, it should be more economically viable, which should be reasonable, should not be expensive so that everyone can choose it. Third, it should outperform other methods functionally and should be better than the existing practices. Now, coming on to 12 principles of green chemistry. So, when the chemist understood the concept of green chemistry, they required some guidelines on how to work or apply green chemistry to the existing process. So, to help the chemist, Paul Anastas and John Warner, who are also known as father of green chemistry, they gave 12 principles of green chemistry, which has to be followed by chemist or whosoever person who is forming a method of producing something, so that pollution can be kept in check. So the first principle is prevention. So obviously, prevention is better than cure. So instead of cleaning the waste produced, if we work on not producing the waste itself, it would be a wonderful initiative. So if we can take example of the paper industry. So in paper industry, traditionally, the wood pulp was converted into paper using the chlorine compounds, which after the conversion of paper was decomposed, discarded into the environment. And where there, they used to pollute the water sources and soil. Now, after the intervention of green chemistry, instead of chlorine or chlorinated organic waste, we are using oxygen, water, and polyoxymetallate salts, which further decompose into water and carbon dioxide, which are a part of nature, and due to the different carbon cycle and nitrogen cycle, they can be taken care of, recycled. Second is atom economy. Atom economy is the amount of substance formed from the reagent that were applied in a reaction. Suppose in given this given reaction, A plus B gives C plus D. So A and B are reagents and they are forming C and D. So where C is the main product. So we did this reaction so that we can get C. We can obtain C. Now, atom economy is saying that how much A and B were useful in formation of C. So what we will do, atom economy formula is mass of C upon mass of C. Sorry, the mass of C is that amount. So after this, we multiply to 100. So the percentage will be, this percentage should be higher. If the percentage is higher, that means more and that will be higher. But if the atom economy percentage is lower, that means the desired product is formed less in quantity while the byproduct is more in number and larger in number. Therefore, the reagents are causing more pollution. This method is not effective. So we have to maintain the methods where atom economy should be high. Less hazardous chemical substances. Suppose there are many conventional methods which are being carried away with the use of many hazardous substances. For example, there are organosulfur compounds which are used in the treatment of skin issues. So those organosulfur compounds initially were made by use of thiophosgene gas, which is hazardous to human respiratory system. So people who are working with that gas for the production of organosulfur compounds, they were getting hazards and they were getting unhealthy. Now, this thiophosgene, as per the green chemistry, is being replaced by other methods like carbon disulfide. So carbon disulfide is a gas which comes in a liquid form, compressed. So if you use it, it will not affect human health. Though it is very reactive, it will do the purpose, but it will not affect the human health. So here, by intervention of the green chemistry, we have made this process safer, and hence we have justified this principle. Next, designing safer chemicals. Obviously, we have to decide those substances when we are using, they form less toxic the toxins in the substance in the environment. Suppose now there are antifollants. Antifollants are added into the paints to prevent the growth of diatoms algae because it's a colloidal based solution in the hull of ships. So you have seen the ship, the metal is there, it is always immersed into the water. So it is covered with the metal, it's covered with anticoagulants, which further prevents the corrosion and maintains the longevity of the ship. So before, these anticoagulants were used as tributylene oxide, which was toxic and it was not decomposing into natural substances and it was going into the water and it was hurting the wildlife in the water, the marine life. So now it has been replaced by C9TM211 anticoagulant, which is a isothiazoline compound. It also serves the purpose while it decomposes easily into natural substance, and thus it does not harm the marine life. Next, solvent. So we use these are solvents and surfacing agents, all the things which do not form the product but they facilitate the product. So they should not be unnecessarily. Suppose if we can do something, some process without the use of any solution, then we should not take it just because it was mentioned in the previous literatures. We should have an understanding if that thing is required or not, or it can be avoided. Next, design for energy efficiency. So the methods should not involve a lot of energy also because energy is a resource which comes from fuel and most of the fuels are fossil fuels, which are not recyclable, non-regenerative fuels. We can save it, right? So they have taken a case study here that in Iceland, they have power-based geothermal stations. So in these stations, the steam is produced underground, where is contact between bottom heat magma or mantle heat, right? So the steam then extracted via a series of boreholes. So when the steam is releasing, they are using the steam as through the boreholes and passing it to the turbines to produce electricity. So now here, see, they are using the natural resources as such. They are not disturbing it, but thus they are using that steam in a different concentrated pipe so that it can create pressure and we can generate electricity. So this is how you use the energy efficiency. Next, use of renewable feedstock. So here we can use all those things which can be renewed. For example, biomass. The plants, the agricultural crops, when they are cut, their remains are lying there, dry. So what we can do, we can use it. Every plant part is made up of cellulose, hemicellulose, and lignin. So what we can do is we can take the agricultural waste. We cannot burn it, and because it's a major problem in the cities, especially in CR, where a lot of agricultural waste is being burned and water, air pollution is caused. So what we can do instead of burning, we can take it, we can treat it, and we can separate cellulose, hemicellulose, and lignin from it, and we can convert into many valuable chemicals. Especially, we can also produce biofuels from them. This is how we are using recycling. We're using and recycling the existing things and not just throwing it away to add more pollution. Next, reduce derivatives. Now, suppose in the reaction, if we go back, A plus B plus gives C plus D, if somehow manage to remove the formation of D, the product will be A plus B, only C will be formed, so atom economy will become 100%. So here they are talking about the same thing, that we should maintain that the formation of byproducts is removed altogether, right? For example, they have given this example of manufacturing of ibuprofen as a common painkiller. So initially it was a six-step process, right? But when the intervention of green chemistry happened, it was reduced to three steps. And as the steps are minimized, the byproducts are also minimized. Catalysis, we all know that catalysts, they do not participate in the reaction, but they initiate the reaction. And when the reaction will be initiated, the involvement of other factors like power, temperature will be reduced, and the resource will be saved. Next is a design for degradation. So this degradation means when we form something and complex byproducts come out of it as a result, it's a byproduct. There should be a phenomenon, or there should be some way or some nature that they can decompose on themselves and get treated by the nature. For example, branched and linear sodium didocarbenzene sulfonate, it's also known as DBS, is used as detergent. It is less toxic, but it does not degrade, right? So if we take the branched one, it will not decompose, but same as DBS, when it is in linear form, it will degrade and get consumed by the environment naturally. So this is how the design is considered. A little change in a design can always change the property of material and can help the biodegradation. Now, real-time analysis for pollution prevention. Obviously, if we are keeping the check on the daily basis, and we are creating a data of how much pollution we are creating every day, or uh, how much waste is being created every day. For example, electronic devices. As we are upgrading our electronic industry, mobile phones, computers, laptops, they're upgrading every day, and the old models are getting into them. So they are also causing the pollution and is adding to the pollution degradation processes, right? So if we keep check on it, we will understand how much waste we are generating every day, and therefore we can manage methods to take care of it. The last principle is inherently safer chemistry for accident prevention. Obviously, we can manage things in such a way that we should not use most hazardous things, like when we can, about the famous Bhopal gas tragedy, where methyl isocyanide was being used. And when it got mixed with water, it created a high pressure and broke the pipelines, and all the people working around, they died as the result of it, because isocyanide is a very hazardous gas. So here we can replace it with using phosphine to form naphthocyclophosphate, which can react and produce carbonyl, which could have saved the people, right? So these are the guidelines of principles of the green chemistry. Now we will see synthesis of identic acid. So first, I am telling you, I will discuss the conventional method, and then how green chemistry had made it better. Here we can see the benzene. Reduction of benzene is given cyclohexane, and further oxidation gives the oximes and benzyl alcohol. Here in this step, we are just alkalizing it and forming adipic acid. Here, byproduct N2O is being formed, which is a nitrogen oxide. It will add with environment in toxic gas. It will make an unsafe environment. While green chemistry, same molecule of adipic acid is formed by glucose. Glucose is a very safe molecule, it's a part of our digestive system also. We are using E. coli, that is a natural bacteria, which can convert it into adipic acid. So this method is a proper natural and simple method and the neutral method, and also it is not giving up any byproduct which is an extra thing and adding to the environmental pollution. Similarly, synthesis of paracetamol conventionally was done by phenol, and you can see dilute H2SO4, NaNO3, all these things were formed as well. Some byproducts are being formed. See, these are two isomers which are being formed. One of them is active, another one is inactive. So this may make a waste. Now, green synthesis, we are making paracetamol from para-aminophenol and acetic anhydride. They are similar to each other, like as not similar, but they're complementing each other in such a way that they react on the room temperature very specifically and form paracetamol and ethanoic acid. Ethanoic acid is a carbonic acid. It can decompose in the environment or it may further convert it into many value added chemicals. Now, environmental impact of green chemistry on society. So first thing is it reduces pollution and source by minimizing or eliminating the hazards of chemical feedstock and reagent solvent products. We have studied about the methods in the principles. Next, for example, we can see dry cleaning of clothes. So before for dry cleaning for the clothes, tetrachloroethane was used. Now it is removed by carbon dioxide and it was a potential carcinogenic agent. So now all the laundries are using liquefied carbon dioxide for the dry cleaning. Second, the use of biopolymer instead of polythene. Polythene is a major cause of the environmental pollution because it is said that all the polythene that has been formed is still existing on the earth and it is not decomposed or destroyed. So here we are using biopolymers. So what we do, corn, suppose there is a corn cultivation, we take starch from that and ferment it and form lactic acid. Lactic acid is a monomer and it can further be polymerized to polylactic acid, right? Polylactic acid, which is a biopolymer. So it works as a class, which it serves all the purpose as the plastic does, but in the environment, after some time, it has a expiry date. After that date, it will start decomposing by the action of microorganisms, and further, it will not create the pollution. Third, global changes, concerns for climate change, oceanic temperature, stratospheric chemical changes, and global distillation can be addressed through development of green chemistry that we have understood. Then, saving resources from depletion due to overutilization of non-renewable resources. Natural resources are being depleted at a very fast rate. Fossil fuels is central issue. To save them, we can use renewable resources in the form of biomass, nanoscience and technology, solar, and waste utilization can be done. Enough food supply. Green chemistry developing pesticides that only affects target organism degrade to simple byproducts. So here, our medicines, here pesticide and pesticides that we are using, they are affecting our plant and we are eating that also. But some pesticides through green chemistry is being developed which will not affect the product, but it will just target the organism so that food can be made organic. Now, removal of toxic from environment, substances that are toxic to humans, animals, the biosphere, and every other organic ecosystem can be currently be released at the cost of health and sustainability. So, in this chemistry, in green chemistry, we can design processes and substances to lower these hazards. And then can use sustainable energy production by using photovoltaic cell, fuels, and bio-based cells. This was all from my side. Thank you so much.